What is this project? This is a disaster detection platform built for the DeveloperWeek 2026 Hackathon. It's a cloud-native AI system that runs on Kubernetes and uses GPU-accelerated machine learning to detect disasters in images. The platform can identify 4 types of disasters: floods, water accumulation in submerged areas; fires, active fires and smoke plumes; landslides, terrain collapse and debris flows; typhoons, structural damage and debris. This system is designed for emergency response teams, government agencies, and NGOs who need rapid disaster detection to save lives through faster response times. The architecture uses microservices with FastAPI for the API layer, Redis for job queuing, PostgreSQL for metadata storage, and GPU workers running PyTorch models for real-time inference. Everything is deployed on Linode Kubernetes engine with horizontal autoscaling. What does the health check do? The health check is a critical endpoint in the API that Kubernetes uses to monitor if the service is running properly. Here's what it does. First, it provides a simple HTTP endpoint at /health that returns immediately without doing heavy processing. Second, it returns 3 key pieces of information: a status field showing healthy if the service is operational, a timestamp showing the current UTC time when the check was performed, a service identifier confirming this is the disaster detection API. Third, Kubernetes uses this endpoint in 2 ways. The liveness probe checks if the container is still running. If the health check fails multiple times, Kubernetes will restart the pod automatically. The readiness probe checks if the service is ready to receive traffic. If it fails, Kubernetes removes the pod from the load balancer until it recovers. The health check runs every few seconds, so it must be fast and lightweight. It doesn't check database connections or external services. It only confirms the API process itself is alive and responding. This simple but essential endpoint ensures high availability and automatic recovery, which is critical for a disaster response platform where downtime could mean delayed emergency response. How the platform works. Users upload disaster images through the API. The API validates the image, stores it, creates a job record in PostgreSQL, and queues it in Redis. GPU workers continuously pull the Redis queue for new jobs. When they find one, they download the image, run it through a PyTorch ResNet 50 model on the GPU, detect the disaster type and confidence level, then store the results back in PostgreSQL. Users can check job status and retrieve results using the job ID. The entire process from upload to result typically takes less than 5 seconds. The platform autoscales based on load, from 3 API replicas and 2 GPU workers at low load, up to 20 API replicas and 10 GPU workers during high demand. WHO benefits from this platform? Emergency response teams get instant disaster classification, saving critical time during the first hours of a disaster. Government agencies can quickly assess damage scale and deploy resources to the right locations. NGOs and humanitarian groups can prioritize relief efforts based on automated damage assessment. Insurance companies can accelerate claims processing from weeks to minutes. Ultimately, the biggest beneficiaries are affected communities. Faster detection means faster response, which saves lives. Every minute counts during a disaster. This platform reduces manual image analysis from hours to seconds, making advanced disaster detection accessible to any organization. Welcome to the Disaster Detection Admin Panel. This web application helps emergency teams detect disasters using AI. On the dashboard, you can see total jobs processed, completed detections, active devices, and a disaster type distribution chart showing floods, fires, landslides, and typhoons. You can upload images for detection by selecting a photo, choosing a device like a drone or camera, and clicking Upload. The AI processes it in seconds and shows the disaster type with a confidence score. You can add and manage devices including drones, CCTV cameras, satellites, mobile phones, and sensors. Each device tracks its location, model, and detection count. You can view all detection jobs in a table with status badges, see detailed results with confidence scores and bounding boxes, and delete old jobs. You can configure API settings to connect to your Kubernetes cluster, test the connection, and adjust timeout and refresh intervals. The panel is fully responsive, works on mobile devices, includes 8 demo devices, and auto-refreshes job status every 5 seconds. Thank you and hope you like this project.